Hello, my name is Zillian St. Hilaire, and welcome to another mini class on mesh networking. Now, I want to talk in this class about the connection between the mesh network and the web service. So, one of the interesting applications of a mesh network, and in our case, we're going to talk about local network, not internet-wide mesh networks, but localized local network meshes. So typically a local network mesh has a couple of nodes, and they're separated from the internet by a NAT or a proxy or some kind of router. And so you have this mesh separated from the internet. Now, one of the things you may want to do is connect this mesh network to a web service. So we have out there in the cloud, we have a server that is our web service, and we want to be able to connect and manage these computers. And there's a lot of applications for this. And what we want to do is have a scalable method. One thing that you could do is have each node keep a connection always on to the website. So each node could do that. In that case, the website would have a connection from the inside to the outside for each node and could send commands to the nodes. Now, of course, if nodes are sleeping or powered off, or in the case of AMT, they're sleeping with out-of-band capabilities, then it's not possible, or not always possible, to have a sleeping node send or open a connection to the outside, especially if there's a proxy in the way. That becomes much more complicated. So what we want to do is create a situation where we pick a leader. We pick one of these nodes to be our leader, and our leader is going to keep a permanent connection to the web service. And so he's going to initiate that connection, and he's going to report on the status of all the neighbors in his mesh area. He's going to report that to the web service. And now if a user connects to the website, he can see all the computers, where they are, what their power state is, and so on. Okay, so the question is, how do we pick this leader? Well, there's a couple of considerations. First of all, we want to be able to make it so that if the leader does not perform his job correctly, if the leader misbehaves in some way, we want to be able to replace this leader. Ideally, we want the web service that's outside to be able to pick the leader. Now, at first glance, this would be impossible because the web service, the website, can't connect in. So you can't go and start selecting which leader you want inside the bunch. But there is a way to do it. The other thing we want to take a look at is we want to be able to have the leader prove himself to others. So if the leader misbehaves, what we want to do is be able to change it. And if he is the proper leader, we want to be able to tie all these nodes to the leader correctly. Okay? So here's what we're going to do. At first, when a node first joins the network, he is going to contact the web service. He's going to contact the web service, and by the way, this is the way he knows to contact the web service and what address. It's in the mesh policy, so we're going to skip that. We're just going to assume that all these nodes know that there's a web service here, and we'll note that this web service has a certificate and they trust that certificate. So let's assume that for a moment we have that. Now what we're going to do is when a new node comes in and joins the mesh, and let's suppose he's brand new, the first thing he's going to do is connect to the web service for the purpose of synchronizing the clock. He has a clock of his own. The web service has a clock that may be different. So what we do is we keep a delta of the clock of an individual node to the website. So we keep that delta. And of course, that delta could shift in the future, but as long as it's roughly in the right ballpark, it's fine. And we'll see that if it shifts, what happens is that the node will eventually just go back to the web server and resync correctly. So it's not a big deal, but as long as it's within a minute from the website here, or a couple seconds. It's perfectly fine. Okay, so now the first thing is each node will go to the website and synchronize their clocks. So we have a common clock now, within rough estimates. Now, what we're going to do is when a node connects to the website can also say, here's the clock, and oh, by the way, you're the leader. Keep a connection to me. So if you're the first node to show up on a network, you connect to the web service says, I don't have anybody around, you're the only one, keep a connection. If a second person joins in, then he would do the same thing. He would go to the website, synchronize the clock, but now there's a twist. It would be nice if all the clocks are already synchronized, it would be nice for you to prove to the other nodes that you're the leader. And the way we're going to do that is that at periodic interval, every 5 minutes, let's say, the website is going to sign, using its certificate, it's going to sign a clock. It's going to sign the timer, and it's going to send that to the leader. And it's going to sign, by the way, the clock and the node identifier of the leader. It's going to sign those two things with a certificate and send it to the leader. Now, this is like a police badge. It's like an identification token. And now this token can be presented to other nodes inside the mesh. And as long as the other nodes are in sync with the clock, they'll be like, aha, you are the legitimate leader. Because we have a piece of information signed by somebody we trust, the website, that has the proper clock within the time that I'm synchronized, and it has your badge on it. It has your node identifier on it. And of course, I can know that you are that node identifier because I did the the mutually authenticated TLS and so on. So each node proves to each other who they are. So when you get this extra piece of information and you present it to all the other nodes can verify that we have a proper leader without having to go to the website. Now, of course, if the leader presents a token that's invalid or presents a token that does not match the clock correctly, then the node would go back to the website, synchronize the clock again, and then maybe once the synchronization of the clock goes through correctly, then the badge will now work. Okay. Now, another thing that's interesting about the system is that if you don't like the leader, if the website does not like the current leader, he can just stop issuing a badge to that leader. In that case, the other nodes will say, whoop, we don't have a leader anymore, and the nodes will start connecting to the website. So one of the nodes will start connecting to the website, and then he can be made the leader. So immediately a badge can be sent to him, and then everybody else will realign inside the network to the new leader. So there's a couple of other techniques we can use. We can use an existing leader to tell somebody else to connect, and then you could have two leaders and so on and so forth. So there's a lot of flexibility here, but this flexibility is all on the server side. It's not on the agents, which is good because the agents are you want to keep them very small, and the rule set that they follow quite compact and easy to follow. So they follow a pretty easy rule set, and the server decides who gets to be the leader and so on. Now, the role of the leader is just to send basically event information about the peers over to the web service. It's also, this role is also to take traffic that comes from the web service, and if it needs to be, relay that traffic over to other nodes. So you have a very scalable system where you use this node as kind of a gateway to route traffic back and forth.